Today we're going to learn about trends in scatter plots. You should be on pages 7 through 8 in your notes packet. The first thing that we're going to talk about today is what we call association. Association is also known as correlation, and you will see both of those words interchangeably. When we say correlation or association, what we are really describing is the relationship between the two sets of data that we're looking at in a scatter plot. The first set of data that you see has what we call positive correlation. When two sets of data have positive association or correlation, that tells us that as x increases, y also increases. You can see that on this scatter plot because as we go further to the right, so as our points get further to the right, they also get higher. So that means that as their x values are going up, their y values are also going up. The second scatter plot has what we call negative correlation. In this situation, as our x values increase, our y values actually decrease. You can see that here because as we go further to the right on our number line, so x is increasing as we go to the right, but our points are actually going down on the y-axis, so the y values are decreasing. The last scatter plot has what we call no correlation. In this situation, there would really be no particular relationship between the x values and the y values. Now let's look at each of these more carefully. Positive correlation is when one value increases and so does the other value, so they both will increase. Here are a few examples. One example of this is the size of a pizza and the cost. If you think about it, as you go from a small to a medium to a large and even to an extra large pizza, the cost gets higher every time your pizza gets larger. So because the size is increasing and the cost is also increasing, there would be a positive association between those two sets of data. The number of hours studied and a grade on a test. Typically, as a person studies more hours, so as that time studying increases, that person's grade on their test will also increase. We always have what we call outliers. So there are always times in situations like these where you can say, well, I've studied for a test for hours before and got a bad grade. You would be considered an outlier in that data because the thing about a scatter plot is that not every point is going to fall perfectly in that pattern. But what you will see is that the majority of points will follow that same association. The temperature and the number of people at the beach. Well, this one would be a positive association because when the temperature is really low, like maybe 0 degrees, you're not going to see a whole lot of people at the beach. But as the temperature increases and gets higher and higher, maybe up to 80 or 90 degrees, you'll notice that the number of people at the beach also increases. So that would be a positive association because as the temperature goes up, so do the number of people who are at the beach. Now let's look at negative correlation. With negative correlation, as one value increases, the other value decreases. Here's an example. The age of a car and the cost of the car. What I would always start with this is look at just the first thing, which is the age of the car. And I would say, okay, what happens as that increases? So as a car, if a car starts out as 0 years old, it has a high price. But as that increases, like maybe my car is 10 years old, the cost of the car is not the same as it was when I first bought it, would it be? So because of that, I know that as the age of the car increases, the cost of the car, instead of increasing with it, actually will decrease. And of course, there are outliers here because there are special cars whose values increase over the years. But most typical cars, as their age gets higher, the cost that it would B, to purchase that car, gets lower. So because one of these is going up while the other is going down, this would be considered negative correlation. The temperature outside and the number of people wearing coats. Well, for this one, if you think about the temperature outside, if the temperature starts out low, so maybe it starts out as 20 degrees outside, there are probably going to be a lot of people wearing coats because it's cold. But as the temperature increases, and maybe it gets to be summer, so as that temperature goes up, you're going to see fewer and fewer people wearing coats. There may still be people wearing coats, but that number has gotten a lot smaller. So as the temperature goes up, the number of people wearing coats goes down. And because one of these is increasing while the other decreases, this would be considered negative correlation. The temperature outside and the amount spent on heating. So you have to be careful and read this one carefully. So the temperature outside, again, as the temperature goes up, so again, I'm going to look at just the first thing. As that temperature increases, it gets higher and higher. So again, if I started at 0 or 20, and now I've gone up all the way to 80, the amount that a person spends on heating their house is going to go drastically down, because once we get up to 80, 90 degrees, people are not heating their houses anymore. They're cooling their houses. So as the temperature goes up, people are not spending as much money heating their house. They're going to change to cooling. So this is going to go down. So because one of them is increasing while the other is decreasing, this would be considered negative correlation. No correlation is when there is absolutely no relationship between two sets of data. Examples of this would be shoe sizes and a person's grades on a math test. Well, as shoe sizes of students in a class increase, so if you line students up based on shoe sizes, you're not going to notice an increase or a decrease on a math test because shoe sizes really don't determine a person's grade on their math test. A person's age and their number of pets at home. Well, typically, as someone gets older, the number of pets that they have at home is not going to increase or decrease drastically. It may increase by 1 or 2 or decrease by 1 or 2, but typically it will not have a decrease that is huge or an increase that is huge. And if it did, that would probably be an outlier. For the most part, there's not going to be much correlation between a person's age and the number of pets that they have. All right, so there are several examples below, and I want you to determine what type of correlation exists for each of these. The best way to do this is to use this. So I would always ask myself, as the first part of this increases, what happens to the second part? So A says the number of toppings added to a pizza and the price. So I would start with, as the number of toppings added to a pizza increases, what happens to the price? Well, the more toppings you put on a pizza, the higher the price is going to be. So because of that, I would say that this has positive association or positive correlation. B says the height of a candle and the amount of time that it is lit. So we talk about the height of a candle first, and I would ask myself, as the height of a candle increases, and this one's kind of thinking about it backwards, to be honest, what's happening to the amount of time that it is lit? Well, if you think about a candle, the more you burn it, the lower it gets. So if the candle is very tall, the higher the candle is, the less time that it has actually been burning. You can also think about it in reverse. So I could have thought about it in this case. As the candle is lit more, so the amount of time that the candle is lit, it increases, the height of the candle is actually going to go down. So because one of them is going up while the other is going down for each of these, that would be considered a negative association. C says the temperature of a cup of coffee and the amount of time it sits on a counter. Well, if we talk about the temperature of a cup of coffee, if I'm looking at the temperature of a cup of coffee and I'm asking myself, what happens as that increases? And I compare it to the amount of time it sits on a counter. Well, I might want to again look at this one backwards. If I think about the amount of time that it sits on a counter, as the time increases of a cup of coffee sitting on a counter, the temperature of that coffee in the cup is actually going to probably go down a little bit. So because the amount of time is increasing, but the temperature of the coffee is decreasing, I'm going to say that this would be a negative correlation. D says a person's shoe size and the number of letters in their name. Well, typically a person's shoe size and the number of letters in their name really have nothing in common. So there would be no association or no correlation between those two sets of data. Now let's also talk about clusters and outliers. We say that a scatter plot has clusters when the data forms what we call separate and distinct groups. Scatter plots will have outliers when there is a point that does not fit the pattern of the rest of the scatter plot. So that would be a point that was way higher or way lower or much further to the left or much further to the right than the rest of the points in the scatter plot. So let's look at this one. This is looking at a basketball shot. The x-axis is showing the shots attempted and the y-axis is showing the shots made. Well, if I'm looking for clusters, clusters are my distinct groups. I can see here that there are two distinct clusters of points. So I'm going to say the data set has two clusters. And then I'm looking for any outliers. Well, an outlier would be something that really doesn't go along with the rest of the data and isn't fitting in. Well, you can see that there is this point right here. This point would be considered an outlier because with that point, it's not in a cluster, so it doesn't really fit in with the rest of the data. So what we can see is that that point is where our x values are 35, which means 35 shots attempted, and our y values are over here, maybe around 17 or 18. So that would mean that after 35 shots, they made about 18 of them. So there is an outlier there. Now in this set of data, we can see that there are 3 distinct clusters. And when you look at those clusters, there's really there's no point that really doesn't fit in a cluster. Because there is no point that fits outside of a cluster, there is actually no outlier in this data.